It's my great honor to be here to share my research experience with you. And I would like to thank Professor Wang for having us here. Also, here is Professor Chengchi, who is the pioneer researcher in the argument study of reading Chinese. So I feel kind of nervous here. I'm from Department of Psychology in National Chengchi University, located at the south area of Taipei City. If you have a chance to visit Taipei Zoo, please stop by to visit me, because we are very close to the zoo. And I'm also affiliated with Research Center for Mind, Brain, and Learning in National Chengchi University. So before my talk, I would like to let you be familiar with me for the research what I have done. So in my eye movement and reading laboratory, there are many 4 lines of research. The first one is we would like to know the early character and the word processing in the Paraphoveal. For example, whether we could access the orthographic, phonological, and semantic codes of Chinese in Paraphoveal. And we also like to know whether we could segment the words in very early process when those information is at the Paraphoveal region. The second line of research is we like to investigate the contextual influence in reading Chinese sentence. So the main manipulation is we use the word capability to create the sentence constraint to study how it could affect reading Chinese and how it interacting with the lexical assets of Chinese. And we also study some issue on Chinese homograph processing. For example, the semantic and syntactic ambiguity resolution. The third line of research, actually, we use the eye tracking technology to study spoken word recognition. There's a so-called visual paradigm, which allowed us to use the we could ask participants to listen a sentence, and we show 4 different objects or words on the screen, and we could analyze the fixation probability on each of the words to address the issue of spoken word recognition processing. The last line of research is we have done some study to study the individual difference in reading Chinese. For example, the learning Chinese as a second language, and then we are trying to compare the reading of traditional Chinese and simplified Chinese, because simplified Chinese basically they simplify some of the character from the traditional Chinese. So what's the cost and the benefit from those simplifications? So far I have 4 students in my lab, 4 PhD students and 4 master students. Some of them are from Department of Psychology, some of them are from Institute of Linguistics. So in my talk, I will start with introducing some of the basics of eye movement recoding, and then followed by 2 studies to show the contextual influence in reading Chinese and how the context could affect the Paraphoveal processing in reading Chinese. So the first question is why the eyes have to move. Because our video system had the limitation for the video acuity, and we also has the limitation for the attentional resource. So when we look at the thing, or when we read a sentence, actually we only a limited region where we put perceive and process the information. That's the main reason why our eyes have to move in order to get the whole picture of the scene or to read the sentence, to comprehend the sentence. So, so what the eye movements can reflect have two main sources. One is the I call it as a video preference or video saliency, because some of the physical features like color, contrast, or brightness could attract our eye to fixate a scene. But the other very important sources is the cognitive preference or our cognitive needs. That means our intention, our experience, our knowledge, our emotion could guide our eyes to move a different area or different location to get those information that we want to see, we want to process. So these two preferences are the main forces to drive our eye to move. That also gives us a chance to use the eye movement data to reflect our cognitive processing. So here is some of the eye tracking systems around the world. So actually they have different kind of setting according to your need for research. Basically, most of the eye tracker we use now is a so-called video-based system. So the eye tracker has a high-resolution camera which can capture the image of eye with infrared illumination. So, so the eye tracker system could identify the region of the pupil. So it can record where how the pupil area move, because our eye moves as the pupil move. So once the eye tracker could identify the pupil region, it would locate the center of the pupil, and it can record all the coordination of the eye movements along the time. But what eye tracker can record objective is the movement of eye. It cannot directly tell us where we are looking at. So we have to follow. We have to perform calibration procedures. In this procedure, we ask participants to look at the black dot on the screen, and the black dot will move to different locations on the screen. So we have the pupil area. So the eye tracker could record the pupil area when the participant look at different black dots. So eye tracker could mapping the eye movement to the fixation locations and to calculate the coordination of the fixation position. So that's the data we could use to analyze in our research. So both camera adjustation and the calibration are important for research to get accurate data. If you fail to perform the calibration, or if you have large error in the calibration procedure, the data will be just garbage, which is not useful for us. So in reading, we could use in reading, we could use the fixation duration and the fixation probability to reflect two main reading process. One is the lexical processing, the other is the semantic integration. So one of the advantage also is most challenging thing is that we could use the fixation. We could generate many different kind of computation for fixation duration. Usually we will identify the target words in a sentence to be analyzed. And we could define some of the fixation duration according to whether when the eye move into the target words. For example, we could compute the first fixation duration or gaze duration to indicate the eye initially entered the target words before it left out to the other words. And that's we also can compute fixation probability to indicate whether the word is skipped or not, or whether the target is refixated or not. So this index, we call it the first pass IMO measures, because those are the measures for the reader, for the eyes initially fixated at the target words before it leave to other location. And the first pass index usually we refer to most research has a consensus about that the first pass duration could indicate lexical processing. And we also could compute the fixation duration with we could compute those fixation duration for those cases that the eye actually move to further words and return to the target. That this fixation. So total viewing time is one of the indicator to have those second pass measures, and we also could compute the regression rate of the target words. And these second pass measures usually could indicate the semantic integration. So, in general, sentence reading includes two main stages. One is word recognition to access phonological, orthographic, semantic information. The other is the comprehension to integrate syntactic and semantic relationship among words. And the difference between these two stages, they are bidirectional. One is the bottom-up, which recognizing words are the element for the comprehension. The other is a top-down inference, that is that context could be used to predict or facilitate word recognition for the following words. So, in Chinese writing system, we the basic right the basic reading unit is the Chinese character. It occupies a rectangular region of the same size and separated by space of equal size in sentence. And Chinese character can map onto morphemes and syllables. And they are composed of radicals, and they are constituents of words. But in addition to character recognition or word recognition, actually things become more complicated when characters are embedded in sentence. Because we don't have the word spaces like English to separate words in sentence. So because we use 4,000 characters, 4,000 often used characters to generate 100,000 words, and most are compound. But when they are embedded in sentence, they have the lexical ambiguity because the word lengths are varied, and because we have the same character can appear in many words, and we have homophones, and we have semantic issue that morphemes carried by character is not always transparent to word meaning. And we also have the word boundary ambiguity because about 80% of Chinese character can appear at more than one position within words. That means we don't have a clear marker to indicate whether the character could be the beginning of words or could be the end of words. So given this different kind of word ambiguity, would Chinese reader could rely more on contextual information to read and to recognize words in sentence. So context could facilitate word recognition by decrease the dependency on visual and the bottom-up processing. So in reading sentence, there could be two sides of the inference that can be effective. One is the foveal or the fixated word. The other is paraphoveal, which is the which has the word next to the fixated words. And they also have two possible type of inference. One is the context to facilitate processing of the visual encoded information. The other is that the context may guess what the next word is and ignore the encoded information. So I'm going to show you a study of ours to ask two questions. One is does contextual predictability influence lexical processing of words? The second question is, does the contextual effect occurs late or early? So we have 32 participants to read 100 sentences, and the main manipulation is frequency, which is the low one set of word is low frequency word, the other is the high frequency words. And we also manipulate the predictability of the words, which the sentence frame is predictable or unpredictable. In order to quantify the word predictability, we use the closed task to measure the contextual constraint. For example, we have a group of participants to perform the closed task. And at the beginning, we will show the sentence frame like here. 商场如战场，没有明确的游戏 and we ask participants to write down the first word came into their mind. So, as you may know, lots of participants will write down the word 规则. So if there are 8 out of 10 participants write down the word 规则, then we would quantify the word 规则. 规则 probability, 规则 predictability is 0.8. And if we use this sentence frame, 高挑美丽的主持人在台上将协会 and maybe only 2 of the participants write down the 规则. So 规则 in this kind of in this sentence frame, its predictability will be 0.2, which is the unpredictable condition. So we have a set of high frequency words, and the other is low frequency words. And for each word, we generate 2 sentence frames. One is predictable condition, the other is unpredictable condition. So as you can see here, the difference between the black line and the gray line to indicate the word predictability effect. All the fixation duration measures showed the word predictability effect. That is, the fixation duration on the target is shorter for those words in the predictable condition than the unpredictable condition. And our result also shows that the word frequency effect was reliable on gaze duration and total wing time, but not on the first fixation duration and gaze duration. Sorry, the single fixation duration. And the result also shows there's interaction observed on the total wing time, which is the second pass matrix. Second pass matrix. So according to the result, our results show that word predictability facilitates both early lexical access, which is indicated in the gaze duration and the single fixation durations, and also the late semantic integration shown in the total wing time. And the early effects of word predictability were independent of word familiarity. So no matter the target word is high frequency or low frequency, the early effect of the context could occur and to help them to be recognized. But for the semantic integration, because we show an interaction in on the total viewing time, so the context provides more support for the unfamiliar words than familiar words. So in this simple experiment, we show that we show the contextual effect on the Paraphoveal words, which is indicated by the first pass duration for lexical access. We also show the second pass. We also show the contextual effect on the second pass duration to indicate the semantic integration. But the following question is that whether the early effect could occur in Paraphoveal, where before the target is fixated. So if the eye is fixated at the Jie-Li, could the context or could the context constraint help to process the 能源 in the Paraphoveal, and it could, and the 能源 could be skipped because of the help from the context. And there's one important factor which could affect the quality of Paraphoveal preview is the launch distance, which is the fixation location prior to the fixation on the target. our data shows that there's a predictability effect on word skipping rate. Words were skipped more for predictable words than unpredictable words. So there's an effect of the context for the Paraphoveal preview. But there were two possible accounts. One is the context could help to retrieve a word without using the visual information. The other is that context could facilitate the visual word processing in Paraphoveal. So we have done the following analyzed to add the launch distance as a covariate to show whether there's interaction between word predictability effect and the launch distance. And the interaction is significant. As you can see in the figures, -3 means the 3 character to the left of the target. So you can see when the launch distance is close to the target, the word predictability becomes larger. So that means contextual information can facilitate Paraphoveal target word preview and subsequently reduce the fixation time on the target. So the context does not get the Paraphoveal information is used by the reader rather than just ignore them to use the contextual information only. So let's describe the Paraphoveal preview in reading more detail. So we could define the Paraphoveal preview as that processing the word N or processing target words can be initiated early when word N is in the Paraphoveal prior fixation. So Paraphoveal preview benefit can be defined as fixation time on word N is shortened when word N is partially processed in Paraphoveal. So in Eichmann research, we use the boundary paradigm with Eichmann contingent display technique to investigate the Paraphoveal preview benefit. In such experiment, we set the invisible boundary at the location before the target. So before the eye crosses the boundary, the preview character could be an incorrect character which shares some of the feature with the target. But once the eye crossed the boundary, the preview character was replaced by the correct target. So basically, the reader could read and comprehend the sentence without any problem. They even did not aware of any change of the display. So we could manipulate the shared feature of the target and the preview. So fixation duration time of target would be shortened for the similar preview than an unrelated preview if the shared feature is processed Paraphoveally. So the Paraphoveal preview benefit in reading could indicate the lexical processing in an early stage of Paraphoveal preview, which cannot be observed in traditional studies, behavior studies. And the early and Paraphoveal preview benefit could indicate the early lexical process in a reading situation with less text demand. For example, lexical decision task or naming task. For reading alphabetic scripts, both phonological and orthographic codes can be accessed in Paraphoveal, but not for the semantic codes. So there are several studies to study the. There are several studies show that there are different kind of Paraphoveal preview effect can be observed in reading, including orthographic, phonology, morphology, and also semantics. I'm going to showing a study to ask to directly examine whether the preview benefit effect interact with the contextual repeatability. We use the boundary paradigm manipulating orthographic and phonological preview, and also the word repeatability of targets. So here is our design of the experiment. We have 4 kinds of previews. So the target character is the main domain. It's so we have the identical preview to show the correct word in Paraphoveal, and we also have 2 different. We have also 3 other preview types. One is P plus O plus, which is main, sharing the same pronunciation and also sharing the same right radical, which is visually similar to the target. The other preview type is P minus O plus, which share the same right radical with the target, but they have different pronunciation with the target. And we also have unrelated preview as the control. And we embedded the target character in the 2 character words many times. The other manipulated variable is the word predictability. So we have 2 different sentence frames. One is a predictable sentence frame, the other is unpredictable condition. So let's focus on the result of the gaze duration. As you can see, the red lines is the condition which the sentence frame is predictable. And the difference between the P plus, O plus, and P minus O plus indicate the phonological effect is larger when the context is predictable than unpredictable context, unpredictable sentence. So our results show that it actually confirmed our previous study. Phonological information of Chinese characters processing early in Paraphoveal, although Chinese is like graphic orthography. And we also show that the context interacts with the availability of Paraphoveal preview, especially for the phonological information. I think that coincides with the nature of the working memory, which is the phonological basis. So in this 2 study, we actually show the interaction between the bottom-up reading and the top-down reading, which is from the inference of context, and also the bottom-up, which can can be shown in the Paraphoveal preview effects. We have done a series of study to investigate the contextual influence on semantic and syntactic ambiguity resolutions. So here is the one of study we have done. So we have a set of Chinese homographs, which have two different meanings. One is the dominant meaning, the other is the subordinate meaning, and we create the sentence frame to fit, to constrain the subordinate meaning, to provide to bias to the subordinate meaning. And our data clearly show that the ambiguous words has larger fixation duration than the homographs or unambiguous words, both shown in the gaze duration and total reading time. So, so context could interact with meaning activation of Chinese homograph, and it could occur relatively early. Also, the effect on gaze duration supports the competition account. That is, the activation of dominant meaning compete with context facilitates subordinate meaning. So, so in conclusion, so in a study which I have shown to you, in reading Chinese, contextual information supports later semantic integration and comprehension, and it could support, the context could support early lexical processing on Paraphoveal words. And the context could affect very early Paraphoveal processing, which is indicated by the Paraphoveal preview benefit. The other message I like to share with you is that the advantage of eye movement recording for reading research is that it could provide online process. It could record the online processing in a natural reading situation. In addition, eye movement recording could provide the time course of the lexical and sentence processing. And we also could use those data to study the Paraphoveal and the Paraphoveal processing. We also could use the data to show the integration of semantic and syntactic structures. So that's the talk of mine today. Thank you.
Okay, we still have time for questions. So please ask questions. Yeah, please.
So just now you mentioned that the phonology effect has on the contextual understanding.
Yeah.
So, but then eye tracking is mainly kind of reading. So how do we predict the phonological effect?
How do we predict the phonological effect? Because each character has its own pronunciation. So we could use two different kind of character, which they are both visually similar, but they have different pronunciation. If there is any difference in the fixation duration can be observed, it shows that difference is caused by the phonological processing.
So the orthography is similar, but then the pronunciation is different.
Yes.
Okay.
Will you expect a similar result if the character is pretty vertical? If the reading is pretty vertical, like book, when you're reading a book, the reading is pretty vertical.
Well, I will expect a similar finding because there's no other reason that I could think of there will be a difference between the vertical reading and horizontal reading.
Thanks for the talk. I just want to ask like a clarification question about the alignment between the cognitive processes like lexical processing, semantic integration, and the parameters like the measurements of gaze duration and so on.
Okay.
So you talk about the first fixation and what's the gaze duration in the first pass, and that may indicate the lexical processing. But I'm thinking that maybe like in that duration there is already some semantic integration going on as well. That's like the readers will be integrating that target would be some preceding context, even if they are not like regressing. We're looking back at preceding context.
Yeah, it's a great question. I think we could not rule out the possibility that the gaze duration could reflect the semantic integration, but it's not exclusive when we referred lexical access in reflected by the gaze duration. We are not saying that it's exclusive for lexical processing. I think that's the proportional difference, because when we first enter in or we first initially look at the words, the primary task is to recognize it, although it could involve some of integration processing with the previous context.
My question follows the question that follows her question. Is there a possibility that the fixation subpart system is separated from the meaning processing system? Because there is a spill out effect in which maybe the when we process words, when we are fixating on a word, we can actually processing the previous word. So I think maybe the time when we are gazing on a word, we are not only processing the words that we are fixating. Is there a possibility like this?
Long time ago, we have two assumptions. One is the immediate processing hypothesis. I mean, the two assumption is proposed by Jasper and Carpenter. So they assume that once the processing stopped, it wouldn't stop until it completes the process. The other is the I-mind assumption, which is assumed that our eyes would not leave until the process has been completed. So that's the basic concept the research is relying on to do the research. So, of course, there are lots of exceptions. There are many studies showing there's an exception for these two assumptions. But I think it is possible that the property of previous work or the property of next work could affect the fixation duration on the current words. But the main contribution still is from the property of the current words. That's why so many research could show word frequency effect or length effect or different or any effects of the lexical properties. So those evidence give us the support that the fixation duration mainly reflect the lexical processing of the fixated words.
Okay, I have a question about eye track technique. So you have mentioned several advantages for using eye track in examining reading for this time. So what are the major disadvantages for such a technique?
Well, I would say no, because I'm doing the research of eye tracking. Not all of the participants could have a good data from the eye tracker, because I mean some participants could follow the calibration procedure, then you could not get the accurate data at all. For example, the older people or some specific individuals who are not able to control themselves or control the motion the motion very well.
Any more questions?
I'm not a Chinese reader, so of course my eye tracking performance on a paragraph like this would be very different from a native reader. But I'm curious as to how consistent are the eye tracking, the eye movement strategies of native readers. For example, do all native readers move forward to a word boundary? And if they do, how far ahead of the previous gaze point is that? Is there consistency in the strategies that readers use? Or are some readers just different from others?
Maybe we should ask Professor Chen to answer this question. I don't think we have the consistent pattern in reading Chinese. So far, it's still a big debate on whether the eye movement could show us how Chinese segment words in reading.
You talked about preview, and that seems to provide an opportunity of paraphoveal information as to where to go to next.
Yeah.
But, for example, does an eye movement typically move to a position within the paraphobia, or does it sometimes jump beyond that? Is that known?
I think it varies a lot
Still very okay.
for my knowledge.
Okay.
So sorry, I have one more question. I noticed that I noticed that the words that you choose as targets are or two-character words. Can you give but if there are words that more than two characters, for example, 3 or 4 characters, will there be a difference in the paraphoveal preview?
Yeah. Most of research use the two-character word because for Chinese words, almost about 80% of Chinese words are two-character words. So that represent the majority of the Chinese words. And of course, the fixation duration would be longer for 3-character words, I think. And also because our paraphoveal, the range of our paraphoveal preview actually is quite limited. So it could show different pattern for those with longer lengths, I think. But I think it still depends on what issue you are going to ask, what question you are going to ask to contrast the 3 character words, because it could be 2-1 compound or 1-2 compound for those 3 character words. So that could be a good possibility for us to study how we segment or how we process the compound using those 3 character words, I think.
Is eye tracking useful for single word recognition?
Okay. I think that's one of the big limitations for actually technology, because the region of one character actually is quite small and condensed. So we have big chance that those single character words could be skipped without any fixation. Then we will lose lots of data for analyze or fixation duration. And also, many of the single character words, actually they are high frequency words or function words.
I have a question. It's related to the Google Glass, because recently it's the Google Glass and you have the screen is very small, so that there is a system when you read an article and then it occurs 1 character after 1 character. Do you think this could help people to increase their reading speed, or is this a negative thing for people to realize the whole article?
Well, I think if we present word by word on the center of screen, it does reduce the effort for us to move our eyes to different locations. But you have to pay the cost of masking, because the previous word actually is masked by the next word. And also you cannot control the speed of the single word presentation according to your own reading speed. I think that interferes a lot to our reading. And also it could make eye tracker useless because your eye don't have to move.
Okay, if no more questions, let's thank for the Tsai again.